Section 7.2, statistic. First of all, I want you to be familiar with some of the symbols that we use. If you see X bar, that means sample mean, or when you calculate the mean for samples. This symbol means mean of population. So when you calculate mean for entire population, we normally use this mean, this symbol. A standard deviation for the samples is S, and a standard deviation of the population is sigma, is this symbol that we use. Formulas are always the same because you either use samples or you use population when you're working on problems. So on section 7.2, we discuss estimating population mean. And there are also some formulas that we are using for that. For population mean. Now, we already use this formula for proportion. For mean, if you want to find the interval for the mean, there are two formulas. One is if the standard deviation of population is given in the problem or is known, then you are using this formula. If the standard deviation of population is not given in the problems, then you are using these two formula. So you understand in either case, formula are the same. The only difference is when a standard deviation of population is given, you're using Z table. And for the other one, when the standard deviation is not given, we are using the T table, which I'm going to discuss very soon. What the T table, what's the difference between T table and Z table? This is a T table. T table has degree of freedom and area of one tail or area of two tails, and these are the value. These are the T values. What is degree of the freedom? Let's say there are 10 numbers and the mean is 80. So let's say I have 10 numbers and I want to calculate the mean. So I add all the 10 numbers and obviously divided by 10 to find the mean. So sum of X divided by 10. So now you could assign any number to the first 9 numbers. The first 9 numbers, you could assign any numbers. But the last number, which is number 10, we have to find a value for that number. When you add all the sum become 800. Because then 800 divided by 10 would be 80. So if you already know that the mean is supposed to be 80, let's say we have there are 10 numbers and we know the mean has to be 80. So that means sum of the 10 number divided by 10 has to be 80. The first 9 number, you could pick any number, but the last one, it has to be a number that when you add to the rest and divide by 10, it gives you 80. Okay? So if the first 9 number you add all together and you come 750, what would be the last number? What would be number 10? 750 divided by that is 50. That should be 50. That means the first 9 number is optional, but the last number is not. So degree of freedom is n, which is 10 minus 1, or 9. So you have a freedom of the first 9 number, but not the very last number. So D of F, degree of freedom, is n minus 1, or 10 minus 1 is 9. So you have freedom to pick the first 9 numbers, but not the very last one. That's what degree of freedom means. So when you're working on the problem in these sections, D of F, degree of freedom, is always n minus 1, number of samples minus 1, and degree of freedom is this column. Like in this problems here, find the critical value of t, 95% confidence, and sample size is n equal 15. Okay, so when sample size is n equal 15, then degree of freedom is n minus 1, which is 14. And there is a 95% confidence level, means if this area is 95%, if the blank area is 95% or 0.95, what's the remaining? The remaining is 1 minus 0.95 or 0.05. So area of two tails is 0.05. Area of these two tails is 0.05, and degree of freedom is 14, n minus 1. So in that case, you go to t-table, degree of freedom is 14, area in two tails is 0.05, or area of one tail. These two are almost the same. This is area of two tails, means this is your alpha, and the one at the top is half of alpha. So that gives you the t-value, 2.145, and that's the number that you see here for each of these, okay? But again, this is if you want to use the table, but then I'll show you how to use the calculator to find the value. In these problems, a bunch of numbers in these examples are given. They already calculated the mean of sample and the standard deviation of the sample, and n are given. So for that, when you have all these informations, the formula for the E is, first of all, why I'm using the t-table, because we are taking the samples here. How do I know we are not using population? Because they are using sample mean and S, the standard deviation of the sample and sample mean. So I know I have to use the formula because standard deviations are not given. So I have to use this formula, E t of alpha half S over radical n. So in that case, we already have all these numbers. We plug into the formula to find the E, and then mean plus E and mean minus E give you proportion of mean populations. Now, if you want to calculate this value of t of alpha half, if you want to use your calculator instead of the table to find t of alpha half, you go to second verse, inverse t, and you use alpha half for it. So here, you go to second verse, inverse norm is for z, but the other one for t is inverse t. So here you put half of the alpha, or alpha half, because you're doing it for one tail, 0.025. df is 14. That gives you 2.145. That's the number. Okay. So this number, the t, instead of table, you could use your calculator to find that number. Again, this is a formula we use when you want to calculate the sample size. And it's Z in it, means we don't have it for the other one yet. In these examples, 95% confidence interval give you the Z of 1.96. Sample mean is within 3 IQ point of population. This is your margin of the error, 3. Sample mean is within 3 IQ points of the population means, and standard deviation is 15. We assume sigma standard deviation of population is 15, so that would be 95 when you round it up. This is another examples. A standard deviation is given, is known. When a standard deviation is given to you, then we are using this formula, which is very similar to this. The only difference is you're using Z instead of T. See, you're using Z for 95% confidence interval. We are calculating the Z and we put it in the formula. And then how do I calculate the population mean? So I'm trying to do this part. It said if you want to use the calculator for it, you go to stat and you go to test. Number 8, T interval, stat. A stat is, you see the data on a stat. A stat is when you want to input the numbers. So in this problem, X is 3.9, I input that, 2.9, I put that one, 15, confidence level, calculate. So that gives me two numbers for the mean that we have here. Interval of the mean. Also for number 9 for these problems. When you see a S, and this means you are dealing with the sample problems, so we are using the T. You understand the difference is just whether we are using the T table or Z table, but this is a sample because this is mean of sample and this is the standard deviation of the samples. And here I'll show you how to use the calculator for it. Very similar to that. Sometimes we give you a bunch of numbers. We don't give you the sample mean directly. Then we are using the formula and put L1. I'll show you when I go through one of the examples. So then I'll show you what's the difference between Dado and a stat. A stat is you already have all the sample mean and the standard deviation, but if you do not know sample mean and the standard deviation, then you use the Dado. Dado means the calculator would go to L1 and read all the information from L1. I'll show you on the next slide. And these are for the homework. I'll put the answers on the bottom for these. Again, remember, to find the t, we need to subtract 99% confidence from 1 and divide it by 2 is alpha half. When you want to use the calculator need to have alpha half. Do not put alpha. Alpha half is what the area that you put on the calculator. df is n minus 1. So that gives you t of alpha half. And then you take the number and put it in the formula. And this is how to use the calculator to do all. If you use the calculator, then you could find the mean interval directly. Again, this is very similar. They're asking just for the interval. You use the calculator. You don't have to use a table. They all are very similar. Now, this is the one. Now, what if we do not give you mean of the sample or standard deviation of the samples? If that is not given, what you need to do, you need to go to Stat, Edit, and you need to input all these numbers. You need to input all these numbers into L1. You put all these numbers into L1. When you do that, see, the last number is 0.93, the first. When you do that, then you go to Stat, go to Test, then T interval. Now, you click on Data. When you do that, calculator understands that all the values are L1. So it does calculate all the mean and the standard deviation for you. And then ask for confidence interval, which is 95% of the problems. So then you go directly into calculation, and that gives you the value of 0.108 and 0.381. Okay, so that's the difference. When you input all the numbers, when you put all the numbers into L1, then the calculator would estimate all the mean and the standard deviation for you. So you don't have to do that again anymore. See, you don't put a stat here, you put data. When you click on data, see here, when you click on data, the calculator understands that it has to go and find the data in L1 and do the calculation for you. These problems, I didn't do it because you have to input all these numbers into the calculator, and they're very similar to the other ones. It's time consuming. You have to do it for male and females to find the interval. This one was just 7, ask you to find, and a standard deviation is none, so we are using the z. Why we are using z? Because sigma is given in the problem. Sigma given in the problems. That's why we are using that formula. Number 8, the pulse rate of 145 randomly selected adult N is that vary from 43 to 103. So for that, sample size required to estimate the mean pulse rate of adult, 95% confidence, and sample mean is within 2 BPM, means that's your margin of error, okay? So for that, if you want to find a standard deviation by rule of thumb, then you subtract these two numbers, divide. This is how to calculate a standard deviation by rule of thumb. When you calculate that, then you could put it in the formula. And that's showing you how to find the z-value. Part B, they changed the, on part B, they're giving you that standard deviations. And the rest is all multiple choice, which I'll show you on this page.